All right, so the last thing I want to talk about is when we're dealing with equations that have just one rational expression on each side, we have an option of either cross-multiplying or fraction busting. So I wanted to show you a scenario where cross-multiplying would be easier, I guess, and then another example where fraction busting would be easier. So for this one here, this would be a scenario where cross-multiplying would be the ideal way to solve it. And that is because there's no common factors between these denominators. So I would have to multiply them to each other anyway. So I might as well utilize a process I believe that you learn in pre-algebra known as cross-multiplying. And it's when you have what we call a proportion. A proportion is something like this. You have two ratios that are set equal to each other. So this is a ratio, that's a ratio, and they're equal. So the way we solved proportions in the past was we would multiply across the equal sign in a diagonal. So we would end up with 6 times x plus 1 on the left side, and then on the other side we'd end up with 5 times x minus 3. So that's just a quick review of how that works. And then you'll notice, okay, we're left with a linear equation now, and I just solve this like any other linear equation. I would just have to distribute the 6 and the 5. I would want to then combine like terms. Now they are on opposite sides of the equal sign, so I will have to subtract the 6 to move it to the other side. And then I want to combine my x's together because I'm trying to isolate x. And then I end up with, well, that worked out nice. 6 minus 5 is 1, so I end up with x isolated. And then on the other side, I have a negative 21. And so that's my solution. And again, you want to just quickly sort of cross-check it with the excluded values. So I notice for this particular equation, I had an x plus 1 in the denominator, so I don't want to let x equal negative 1. And then I had an x minus 3 in the denominator, so I don't want x to be 3. But this solution is neither of those, so this is the correct solution also for the rational equation up here. So that was an example where cross-multiplying would be the easier route because my denominators did not have any common factors. But if you notice over here, it again is another proportion. I have a proportion here because it's this ratio equal to that ratio, it's a proportion. But what I notice, if I factor this denominator here, I notice it's a difference of squares, and it factors into x plus 7 and x minus 7. So I notice that I have a common factor of x plus 7 between my two denominators. So in this case, my LCD would be the better route because the LCD is just going to be the common factor of x plus 7 and then times the remaining factor of x minus 7. So it's just those two multiplied together. So it's going to be easier for us to just multiply this over 1 to both sides because it'll cancel both denominators out completely, but the expressions in the numerator won't be overcomplicated. See, if I did cross multiply, so don't write this part down, I just want to show you. If I did cross multiply these, I would end up with 2x cubed because I'd be multiplying x and x squared, and then minus 98, sorry, it took me a second, minus 98x on the left side, and then on the right side I would have like 36 times x plus 7, and then I'd have to solve this cubic equation. Well, so don't write that down because I want to show you how if I multiply by the LCD, the equation I'm left over with at the end is going to be linear. So what I'm going to do instead is multiply both sides of this equation by my LCD. So on this side, I multiply by x plus 7 times x minus 7, and then I do the same thing over here over 1. And that's why I'm allowed to do it, because I can multiply whatever I want as long as I do that to both sides of the equal sign. So I notice on the right side, now remember we had factored that earlier to say x plus 7, x minus 7. So that's what this equals. So those both cancel out. So that cancels and that cancels. So on the right side, I would just be left with 36, not 36 times x plus 7. And then on the left side, the x plus 7's cancel, and then I'm just left with a 2x times x minus 7. So I am left with a quadratic equation to solve, but I would much rather solve a quadratic equation than a cubic equation. So I'll go ahead and distribute here. And then again, because I ended up with an x squared, I'm going to want to switch gears. I notice it's a quadratic equation. So this is where you're going to want to switch gears and set one side of the equation equal to 0, simply because of the fact that one of your x variables is squared. So I notice that when I get here, I have like a traditional quadratic equation. I'm going to try solving it by factoring because, again, that's the method I prefer. So what I notice is that there's a common factor of 2, like each of those numbers are even. So I'm going to take the 2 out. And I get 14 turns into 7, 36 turns into 18. So then this leftover part right here, I will factor with the box. It's just nicer to work with factors that are smaller. So for x, the only thing I can do would just be x and x. And then for 18, I could either try 6 and 3 or 9 and 2. And I'm going to go with 9 and 2 since I'm trying to get whatever ends up here and here to add to 7. So I'm going to make my 9 negative and my 2 positive so that I get a negative 9 there and then a positive 2 here. And then I can see that that would in fact add up to negative 7. Yay! So then that's one factor, and then x plus 2 is the other factor. So now here's what I have. I have 2 times x plus 2 times x minus 9 equaling 0. And then to solve this equation, I take my factors that have x's in them. I don't need to worry about the 2, just the factors with x's, and I set each one of them equal to 0, and then I solve for x. So I get x equals negative 2 as one answer, and then x equals 9 as the other answer. I just want to go back to my original equation and make sure it doesn't conflict with my denominators. So I'm going to erase some of this stuff I had. So my denominator in the first fraction, was x plus 7. So I know that I wouldn't want x to be negative 7. And then here, when I factored the x squared minus 49, I noticed I also had a factor of x minus 7. So I also wouldn't want x to be positive 7. So I just can't let x be either of those. But neither of those are 7 or negative 7. So both of these would work as solutions to my rational equation. So that's it. There's going to be a few more practice slides for you in the quizzes, and then you will be done with lesson 4.8. Nice job.